Okay, so looking at this first one, whenever I have to solve these, if I'm doing it by factoring, then what do I need to do first? Make the little TP. Okay.
The tree triangle.
Triangle.
That's a pyramid.
I'm going to go with triangle. Y'all can go with whatever. Okay, so 1 times 63 is 63. Then, what factors of 63 add up to negative 16?
7 and 9.
Negative 7 and negative 9. Am I done with this problem?
How do you get x? Oh, never mind.
What else do I need to do? Okay, and what tells me to do that one extra step?
Because it doesn't say x equals. It's the first one.
It says what? It says solve. Okay, or
Oh, so
if it says equals 0, usually you'll be solving. So that's
so
it.
when would you do the x minus 9, x minus 7?
If it said to factor,
Oh.
then you would stop right. Oh, you would stop right there. That's all.
What if you don't stop and then x equals 9?
I don't know. Then you didn't do it right. All right, going to number 2. What do I need to do first on number 2? No.
Make it equal, like all one of them.
Put the
Subtract 3.
minus
Subtract 3. Thank you. That's nice and simple. Now what do I do?
TP.
The little TP. Okay. 3 times negative 3 is negative 9. What factors of negative 9 add up to positive 8? 9 and negative 1. Now, I know it's not said. I don't want to say this. Is there anything else I need to do now before I do x equals? What? Why do I need to divide them by 3?
Because there's a 3 in front of the x.
Because there's a 3 in front of the x squared.
Oh.
Okay? So on the previous one, it was just x squared, so we didn't have to do that. This one has 3x squared. 9 divided by 3 is 3. Where do I put this 3?
Under the 1. Like negative, or 1/3.
Nope.
You put it to the
Oh, in
left.
front of the x.
I put it in front of the x.
That's right.
And then now whenever I get those, now I set those equal to 0 and solve. And that's where I get my solutions. Okay? So if you have factors, you won't have a fraction. That's just kind of one of those general rules that if it's in factored form, you won't have fractions. Yes, and I get what you're saying. I mean, x minus 1/3, you would just add 1/3. It's the same thing, but you won't. It's all
Like
the best explanation I can give you. Whenever you have something like this. And let's say you're trying to get it to standard form, what the problem originally was, you would rather do FOIL with that than that. Because now you've got x squared, negative 1/3 x, 3x, negative 1, and it's easier with nice, neat whole numbers. So, getting into today's stuff, we're going to look at solving quadratic inequalities. So, solving quadratics, that means factoring. And now we're going to have inequalities, which means our answer is not necessarily, the majority of the time, it won't be just one number. It's going to be a range of numbers. Okay, and so we'll walk through this first one, this x squared minus 2x minus 3. So it says to solve one like that, you can use the fact that a quadratic can only change signs at its roots. Between 2 consecutive zeros, a quadratic must be entirely positive or entirely negative. We will call these intervals test intervals. All that's saying, in a nutshell, is whenever you're looking at a parabola, all right, between here and here, it is all negative. Okay? between here, this whole part would all be positive. This whole part would all be positive. Alright, so what we're going to do is we'll solve the inequality just like we solved the problems in the warm-up. But your range of numbers that is going to satisfy the inequality are either going to be, I'll do it like this, these x values or these x values. Okay, it's either inside or outside the parabola. Okay, so to find the zeros for the quadratic by factoring the inequality x squared minus 2x minus 3, and it says mark them on the number line. We're going to call those, this says critical numbers, it's the solutions, it's the roots. Okay, that's all it is. So if I factor this, make my little TP here, what factors of negative 3 add up to negative 2? Do what? Negative 3 and 1. And so my two solutions are negative 1 and 3. So I'll go down to the number line, which the number line is all out of whack, because you can tell the little marks get further and further in between the actual numbers. But I'm going to use, here's negative, there's negative 1, and there's 3. Now, somebody tell me why I did an open circle on those.
Because it's not equal to.
Because the inequality was just less than. It was not less than or equal to. So, I'm going to factor it. I'm going to get the solutions. I'm going to put it on the number line. And then after that, I'm going to roughly draw a parabola. You're always going to have a concave up parabola with how we're going to solve these. But what I need you to look at is I need you to kind of see this in 3 different sections, broken up by when the parabola crosses that number line. Alright, so you've got this first section, you've got this second section, and you've got this third section over here. Now, this part of the parabola, I kind of already said this part of parabola, would it be considered positive or negative? Positive, because it's above the number line. Okay, so positive. Section 2 would be what? Negative. And then the last section would be positive. So now, whenever you write your answer, essentially you're going to write the domain for in between those 2 points, or for the areas outside those 2 points. Alright, now I've got a lot of people in the past, I've had a lot of people in the past, that whenever they do their number line, they always forget to put the negative and the positive infinity for those that require, and some of those that did that, they started to write that, and that just kind of helped them. It's, you know, I put that up there, and you probably think, well, duh, it goes to negative infinity that way and positive infinity that way. But that helped to remind them to put that in their answer, just because it was there. All right. So if I was to write the domain for this, the part for section 1, what would that be? Negative infinity to negative 1. Does the negative 1 need a bracket or a parentheses? Parentheses. What is the domain for section 2? Negative 1 to negative 3. Parsa, what is the domain for the third section? Sorry, it should be positive 3. I don't know why I put negative.
Infinity to
3 to infinity. Always put the lower value first. Alright, and then we would need to decide, and this question is actually on the next page. We did what this said to do, but I'm going to make a point on this before we turn it over. It says choose the values that fall within each test interval, okay, which is what we did, to determine if the interval is positive, negative, positive or negative for this particular function. So make sure that you know greater than 0, that's positive, but that's asking for the part of the parabola that is above the x-axis, or above the number line, however you want to see that. So anytime it's greater than 0, you're going to be looking at sections 1 and 3 for your answers. If it's less than 0, that is going to be the part of the parabola that is below the x-axis. So what would be the answer for this specific inequality? Is it 1 and 3, sections 1 and 3, or is it section 2? Section 2, because it's asking for the one that is less than 0, or the part of the parabola that is below the x-axis. Okay, which that is -1 to 3, which we'll put that at the very top on the next page. There it is in inequality and interval notation. Remember, I do not care which way you write that, but you need to make sure you know how to read both ways. Because you may have a test that has answer choice A is in interval notation, answer choice C is in inequality notation, whatever. Question below it says, what would happen if the inequality changed to less than or equal to 0? How would my answer change?
The dots would be, oh, that's not
Okay, if I was on the number line, the points would be filled in, and then what, Mackenzie?
you have brackets around the numbers.
I would have brackets here, and then I would have the equal to signs there. So we're going to go through, we're going to do 1 and 4 together, because 4's got something in it that's a little squirrely that I want you to see. But number 1's pretty basic, so we'll go through it real quick. So first thing, I need to look at it. I need to factor it. So what factors of -6 add up to -1? Okay. Which one needs to be positive and which one needs to be negative?
2 and -3.
Positive 2 and -3. So that gives me what two solutions on the line? 3 and -2. So I go to the number line. Logan, open or close circle?
Close circle, open circle,
Why?
because spacing. Wait, no.
Sarah, help her out.
Because
No. Kyla?
It's not equal to.
It doesn't have the equal to underneath the inequality. Okay. So I've got that. Again, how we're going to solve this, you don't have to worry about a concave down parabola. And so this is asking what part of the parabola is less than 0, or which part of the parabola is below the x-axis. So is that going to be kind of section 1 and 3? Section 2. So it's going to be between -2 and 3. Next, let's go to number 4. What do I need to do first on number 4? Yes, Mackenzie.
I have a
always just gonna be your answer?
Is it always just going to be your answer?
Okay, so,
Let's do one more and see if you still have that question.
okay.
Okay. So going to number 4, and I think someone already said it. What do I need to do first? Add 8. So that's going to give me negative x squared plus 2x plus 8 is less than 0. Okay, and so I said that you're always going to deal with a concave up parabola, which means what part of this equation do we need to get rid of? The negative. So whenever I divide both sides by -1, what is that going to do to all of this? It's going to change all the signs. So I'll have x squared minus 2x minus 8. 0 divided by -1 is 0. What does that do to that sign right there? It flips it. Remember, multiplying or dividing by a negative is going to flip that. And so now, what factors of -8 add up to -2? -4 and +2. And so that's going to give me 4 and -2. Sorry. Now, if you're not given a number line, okay, watch this really closely. This is really cool. What you can do is you can draw your own, just like that, and now you have a number line. Okay, so I would highly recommend that you do that. So I've got 4. I've got -2. Do I need open or closed circles? Open. Okay, and Keenan, am I looking at the part that is above or the part that is below?
Part that is.
Remember, that is the one we actually factored. So that's the one we need to look at.
Oh, below?
Greater than
Oh, above.
above. So that's going to be sections 1 and 3, correct? Okay, so I want to write the domain separately, and then we'll talk about what it looks like together. So what would be section 1, this over here? What is the domain of that part? Okay, -infinity to -2. What about this one? 4 to infinity. And we talked about this little thing at the very beginning of the year, or towards the beginning of the year. That if you have a gap in the graph, use that union sign. Okay, because we're doing the domain for this section and this section. So there's a gap in between those two. So you use that U, that union sign. That's what that is saying. Here's the answer to number 3. Okay, so there's the work for number 5 as well. Alright, so go to this next page. So this is talking about those different situations that you could possibly see. And I'm going to talk about these out of order because I think it just makes a little more sense. It's grouping them. So looking at A, it says the solution set to a quadratic inequality can be all real numbers. This occurs when the function lies completely above or below the horizontal axis. So, that situation, that's when you're looking at a parabola that does not cross the x-axis at all. Every situation we've talked about so far, it did. So if you're looking at this, and the equation is asking you how much of the parabola is greater than 0, well, all of it is above the x-axis. So it would be all real numbers. Looking at C, if you had the same thing, a parabola above, but your equation, your inequality, had your equation is less than or equal to 0, so it's asking how much of the parabola is below the x-axis, that would be none. So your answer on that would be no solution. Okay, so you can have all real numbers, you can have no solution. Looking at B, it says a solution set can consist of a single real number, and that can be that critical number or whatever that root is. So what that would look like is if you solve it and your parabola comes down, touches the x-axis and goes up, and you're asked what part of the parabola is less than or equal to 0. So there is part of the parabola that is equal to it because it's right on it. So your solution would be whatever that number is. Okay, so whatever, x equals 2, if that's what it is. And then on D, very similar situation. Let's say you have that exact same graph, but now the equation is asking, okay, how much of that is above the x-axis? So there's part of that parabola that is not above, it is directly on it. So you would include everything to the left of that red dot, everything to the right of that red dot, but you would not include that one x value. And so it would look something like that. Okay, so a lot of it is in the small details. Does it have the equal to under it? Does it not have the equal to under it? Okay, especially with these two situations. That one's pretty obvious. Is it above or below the x-axis? Okay, so let's look at how these four, how they kind of play out as you work through them. So looking at 6, and one good indicator that you have a parabola that does not cross the x-axis is whenever you can't factor it. Because what factors of 4 add up to 2? What's 1 plus 4? 5. What's 2 plus 2? Okay, and those are the only two sets of factors for 4. So there are no factors of 4 that add up to 2, which means you have a parabola that does not cross the x-axis. This one specifically, I think, is roughly somewhere right there. Okay? So it's asking how much of the parabola is above the x-axis. So what would my answer be? All real numbers. You can put that, or if you want, you can put the all real number sign. Does not matter to me. Going to 7. What factors of 1 add up to 2? They do. 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. So on this one, what is my only solution on this? Negative 1. Okay, that's the only spot on the x-axis it's going to touch. So I'm roughly looking at something along the lines of this. Now it says, what part of this parabola is below or on the x-axis? X equals negative 1.
Why would you get x equals
Okay. Because if you look at the inequality, and I'm going to kind of go through those here in a minute. The way I read this, whenever I'm doing these, is I read that as below. So how much of that parabola is below the x-axis? No, how much of it is below? None of it is below. See this?
Yeah.
So below is the opposite of on top of. So below or on okay, or above.
Yeah.
It's all above, right? So none of it's below.
Yeah.
But then that equal to. So this is asking how much of it is below or on the x-axis. The only x value where that parabola is touching is x equals negative 1. Okay, looking at number 8. Again, you don't have you can't factor it, so you've got some parabola that's above the x-axis. So how much of the parabola is below the x-axis? None. So no solution. Last one, number 9. What factors of 4 add up to negative 4? Negative 2 and negative 2. So what is my only solution on this? X equals 2. There's not necessarily. I'm just doing this up here to show it to you. I think it helps some people, but you don't necessarily have to. So whenever I look at this, how much of the parabola is above the x-axis? No. Do what?
All of it except
All of it except 2. So you have from negative infinity to 2. You've got to do parentheses because it's not equal to 2. You have that union sign, and then 2 to positive infinity. Okay. Now, maybe somewhere on here, you might write this, and you might have been noticing that this is kind of the way I was saying it. Whenever we had these situations. So if it is less than 0, am I looking for the part of the parabola that is above or below? If it's less than. Below the x-axis. If it is greater than 0, I'm looking for when the parabola is what? Above. Whenever it's less than or equal to. Okay. On, let's say, below or on x-axis. And then greater than or equal to. Above or on. So I think if you can put that part of the inequality into words, into those words, and you're looking at the graph, that's going to help you figure that out.